So we've already seen that least squares regression lines, or lines of best fit, can help us make predictions about response variables based on explanatory variables. For example, I have a data set here. On the x-axis is the temperature outside in Fahrenheit, and on the y-axis is my mile time. Now in this video, we're going to talk about how wrong our predictions are.
I've made a huge mistake.
Let's use this point as an example. On this 90-degree day, it took me 11.3 minutes to run the mile. This is our least squares regression line. So let me just do some quick calculations here and see what the predicted time of my mile is. Okay, 11.9, let's call it. So this least squares regression line says that on a 90-degree day, it should take me 11.9 minutes to run a mile. But how long did it actually take me? 11.3. Not bad. That difference in the predicted versus what actually happened is called a residual. Maybe you've heard the word residual in everyday life. Like if you go shopping at Goodwill and you get any kind of dishware, and there's a sticker on it, you peel that sticker off and then you can still see where it was. Like it's still kind of sticky. And even after you put a bunch of Goo Gone on it and wash it in really hot water, there's still a little bit of residual stickiness. Definitely not happened to me. A residual in a scatter plot is a similar thing. Here's what we predicted, but here's what actually happened. That difference is the residual. So in general, to calculate a residual, you take the observed value minus the predicted value. It's really important that you subtract in that order, and when you forget, just remember that it's alphabetical. Observed minus predicted. So in this case, the observed value was 11.3 minus the predicted value, which was 11.9. So my residual for this particular day was negative 0.6 minutes. The negative is really important. A negative residual tells us that our observed value is below the least squares regression line, and a positive residual tells us that our data point is above the least squares regression line. So like remember with z-scores when I said positive and negative was important because it told us what was above and what was below the mean? It's the same idea here. The positive residual means the point is above the line, negative residual below the line. Now we can take all of those residuals and plot them, and this is called a residual plot. So that line going straight across is 0. Take a second and think, a residual of 0, what would that mean? A residual of 0 would mean the line perfectly predicted. The observed and predicted values were exactly the same. So any of these points that are close to 0 are really small residuals. It means the line was very good at predicting on that day. Anything that's further away from the line has a bigger residual. It means the line was not as good at predicting. Now, looking at these residuals, you might notice a pattern. We've got positive residuals here, then mostly negative residuals, and then we go back to positive residuals. In general, you want to see no pattern when you look at the residual plot. We want to see a cluster of points, about half above, half below, and no clear pattern. Unfortunately, I kind of see a pattern with this. It's almost like a parabola pattern. And now that I notice that on the residual plot, I can see it on the scatter plot too. These points are above the line, then we switch to below the line, and then we switch back to above the line. If you see a pattern in the residual plot like this, it means the line is probably not a good predictor. Now, if you look at the R, or the correlation coefficient for this data set, it's 0.834. That's pretty close to 1, but remember, R can't be the only factor in deciding if a least squares regression line is actually good at predicting response variables. When I look at the graph, I'd say it's fine, but I think we could do better. Now what I'm going to show you next is outside the scope of this class, but I want to show you anyway just so you can kind of visualize. If I use a quadratic, like a parabola, instead of a line, I get a much better fit. Like look at how close all of those points are to the parabola. And if I make a new residual plot using that parabola, I don't see that over, under, over pattern anymore. Now it's more scattered and random. This is a much better model than the line. Just to be clear, you don't need to know how to make a quadratic model, but you do need to know how to recognize patterns in the residual plot. And if we look back at the original residual plot, I can clearly see a pattern there. I'm from Minnesota. I don't do well in the heat.